Okay, we're in 10.4 day 2. Today we get to talk about the surface area of cones. Before we do, I want to do a little checkup on your formulas. So, when everyone is still, we'll do that. You don't need to write this. This is just a little checkup on your formulas that you understand and that you remember them, right? So you need to, as you can see, you need to know these formulas because we keep using them again and again as we're using our 3D, as we're finding surface area of 3D figures. We'll use them for volume as well. So we need to remember the area formulas first. So the area of a parallelogram, finish this statement please. A equals BH. Let's do it louder. A equals BH. Good. Finish the statement. The area of a triangle. A equals
BH over 2.
Good. Finish the statement. The area of a trapezoid. A equals
B1 plus B2 times H over 2.
Good. And in both of these cases, you could actually say 1/2 times these things, right? But we like to just put it all over 2. Area of a circle. A equals
pi squared.
You guys are doing great. And I didn't have a symbol for pi, so I wrote it out there. Okay. Circumference is not area, but because we use it to find the perimeter of a circle, we have been using it a lot as well. And we're going to use it today. We're talking cones today, right? Yeah. So circumference, C equals
pi. No, wait,
when we say it, let's say it with just two symbols. C equals
pi d.
Let's say it with 3 symbols. C equals
2 pi r.
2 pi r. So 2 r's is a diameter. 2 radius equals a diameter, right? Good. So you should be really comfortable there. If you wanted to review that again, you could go watch this video, right? And you could review these things. That might be good for you. Okay, let's look at the formula for 3D figures that you should know by now. Let's talk prism. The first question is, how many bases does a prism have? A prism has
2.
Okay, and what shape is the base of a prism? Is it a circle or a polygon?
Polygon.
Good. So if we're going to find surface area for a prism, you had to start by thinking of the number of bases. Okay, now that you have that, let's do it. Ready? S equals 2
plus pH.
Good. 2 base areas plus the perimeter of the base times height. Good. Now a cylinder, how many bases does it have?
2.
Cylinder has 2. And what shape are the bases? Circles. So let's be more specific. It uses this same formula for surface area, but instead of saying base area, give me the area of a circle then, right? Instead of saying perimeter, give me circumference, right? Okay, let's say it. Ready? Surface area equals 2
pi r squared plus pi d times h.
Good. Okay, and here it just is in the terms of circumference, right, which is pi d. I liked hearing you say pi d because that is why it's more specific. Do you see the connection? Thumbs up if you see the connection between prisms and cylinders. Good. Hopefully you all do. Okay, cones we're going to get to today, so I guess we'll come back to this at the end of the day, and we'll do these 2. Okay? So let's go over here and talk about a cone. You know what a cone looks like?
Like a snow cone.
You've already said, right?
Yeah, snow cone.
So it also has a slant height. There are 2 interesting variables in this equation. We have a slant height, which you can imagine is from like the outside rim of the cone up to the vertex. And then we have the radius, which is the cone's circle base. Radius of the circle base. Let me get an image of a cone. So if we draw a cone again, we have kind of a vertex opposite a circular base, right? So the slant height is like what we saw yesterday, going from the outer edge to the top, this way. Okay? And the radius that we use is actually what we find in the base itself. The circle has a radius there. Okay? So the net that you're receiving for a cone looks like a circle, and then we have kind of a part of a circle. Now this lateral stuff, this lateral edge can change. You could have a bigger part of a circle or a smaller part of a circle out here, just depending on how wide your cone is. If you have a really wide cone, you might actually have almost like half a circle with, still the base is always a circle, okay? The one that we're making in our models looks more like about a quarter of a circle. But again, this will make a wider cone. Imagine a big wide cone versus a skinnier cone, okay? And we can try that cutting different things out. But the slant height is this distance here, which looks like a radius of some piece of a circle, doesn't it? Do you see that? If that outside lateral area went all the way around, it would form a circle, but it's just a piece of it. So this is an interesting part of the formula. So first, we know that we have to find the area of a circle, which is the base. And area of a circle equals pi r squared, right? And then we got to find this part of the cone, this lateral part, which is made up of pi, because you can see it's part of a circle, pi times the actual radius in here of the cone and times the slant height. Doesn't that almost look like pi r squared? Doesn't it? I mean, if L was r, we would have r squared here again. But L is a different value than the radius of the base. Okay? There's a fun way I like to say this. The surface area of your cone is pi r squared plus pearl. Looks like a pearl. Doesn't it look like a little pearl sitting there?
Oh, yeah.
Pi r L. It gives you the surface area. Let's do it. Let's find the surface area of a cone. We have a cone with a radius 4 and a slant height 10. Now, sometimes you will receive the information in an image like that and words both. Sometimes you'll receive the information just like this, words alone. When you do receive the information that way, you could go create this, right? Which helps in geometry to have that image in front of you. So remember, draw the figure as often as you can, so you have it in front of you. And then we always start with our plan. So our surface area equals the base, which is a circle, plus pi radius L, pearl. Let's substitute the known value, shall we? And let's see. Sophia, can you do it for us? Leave pi as it is, okay, right now, and then we'll do that at the very end. Or squared, and this is area, so we're going to have centimeters times centimeters. So we'll just go make a note down here, centimeters squared, so that we have less letters in our equation. 4 times, I didn't hear it, good, 10. Okay, so she's substituted all the correct values there. And we simply need to know 4 squared. 4 squared is?
16.
Good, we've got 16 pi here, plus, what is 4 times 10?
40 pi.
40, so 40 pi there. And together we have how many pi's?
56.
Good job. Okay, now if you are using a calculator for pi, you would use the pi button. It gives you more digits, which is a better approximation. If you're doing it by hand, you could use 3.14. What is the fraction that we sometimes use as an equivalent for pi?
22 over 7.
Let's use that here. Why am I saying that?
Because 7 goes into 56.
Very good. It goes into 56. So 56 times 22 over 7. 7 goes into that how many times? 8. And now 8 times 22.
160.
160 plus 16.
166.
176.
Good job. Good job, 176.
Centimeters squared.
Let's write the other values that we use for pi here. 3.14, 22 over 7, or we can use the pi key on our TI 362S calculators, and that gives you a longer approximation, which you would have to round, okay? Okay, we're going to run through these. Please go ahead and find the surface area of these cones. Pause and come back. Okay, so here we walked through the first one. The other two answers are available, and you should have written every step down. Okay? We have composite figures now. Composite always means like a combination, right? And combination, composite figures, we could be finding volume. In this case, we're finding surface area. This is the tougher one to find. It will be easier when we find volume. The reason this is tough is this composite figure has two figures. Do you see that? And so if we wanted to find the surface area of this shape, we would have to find just the visible parts of these two figures. Are some parts of these figures covered? Do you see that? So how would you describe this figure? What do we have there? This tall part down at the bottom would be called, everyone, a
Rectangular prism. Yeah.
okay, everyone together, a rectangular prism. This little piece on top would be called a well, it's actually square, huh? Square pyramid. So the bottom of that pyramid is not on the surface anymore. It is covering this top part of the prism. So that is not there anymore either. So when you have a composite figure, I expect you to make a visible plan. Super important. That shows the combination of the shapes. And then be careful, two sides are covered. So the total surface area here could be the prism. Take away that one side, right? Take away one side. I don't know if you want to call it the base. Some of you will call that the base, one of the two bases. We have options though because it's a rectangular prism, right? And then we're going to add the square pyramid surface area. And what side will we take away from it? It will take away the base area, right? Because it only has one base. That base is not on the surface of the figure. Okay, so right now we know that the original prism, if we consider the very bottom to be the base, then we can actually take away the one side in our formula. Do you see that? Prism formula gives us two base areas plus a perimeter of the base times height. But in this figure, we could just take away this top by taking away one of the bases, as long as we consider the bottom the base. Okay? Let's continue down with just the prism, and then we'll talk about the pyramid in a moment. So we have said the base is, I heard you say it was a square. And a square is BH, right? Or SS, side times side, S squared. So we're using the very bottom, so we better fill that in before we forget. 16 times 16. And then if you take the perimeter of that base, 16, 16, 16, 16, what do you get? I heard it good, 64. And then the height of this prism is, height is? 35. Okay, we have all that information there, and now I'm running out of time for the video, so I'm going to have to pause you guys. Okay, so we're going to walk around the perimeter times the slant height over 2. No base, because the base is touching down, it's not on the surface. Okay, ultimately we had to do a lot of multiplication and addition, and we have this composite surface area. So the plan is vitally important. Right? Yes. Okay, here's your assignment, and you may begin.